Okay, it's time for some fucking battle. I'm going to use the profiler and we're going to make 5,000 game objects of this game object. We're just going to copy it 5,000 times. It's going to run some logic and action. This is the thing that's going to do it for us. So this one little object here is going to loop 5,000 times. In that loop, we're going to add so we can count, so we can make sure. And this is all happening in one frame. We're going to create a copy of this guy under this guy is just to keep it organized, and we're going to finish and then do nothing. So we're going to have 5,000 copies of this guy. This guy, we're going to do a bunch of different things. So the first thing is we're going to do an int add. Let's see how fast it goes. So this is 5,000 Fsms running, all doing int add. And if I click somewhere and I go to our player loop, I can see in our update we're running roughly about 5. So 5.1 for int add. Next we will do the expression. The exact same thing. We're just going to take an integer and add 1 to it. Literally the exact same thing. We're comparing it to... Okay, so here is the expression for int add. So this is the normal int add here that we had, and this is the expression of int add. Pretty big frickin' difference, right? 26 compared to the 5. Pretty big. So next up we have, so let's get rid of this one. Let's do translating. Let's translate 5,000 objects and see how the performance is. Okay, so here is translation. And it's not as heavy as the expression, it's heavier than the add. We can see it is at 9. Not bad. Let's get rid of that one and let's do a get property. Let's get the get and set properties are reflection coding, so let's see how that works. So here's the reflection coding of the get set properties, and you see it looks slightly higher than the last one we had. It's not bad though, you know, 12 almost. Yeah, a little higher. So the reflection coding is rough. You're better off with actions, that's for sure. So before we get into these two, because I'm sure those two are going to be the ones you guys really want to see more so, let's get into this guy. Now I can alter this thing and I can say, instead of finishing and doing nothing, let's finish, oh I have that there, and broadcast every frame. So these guys will have an event. Nothing happens in the event, so it's just catching the broadcast event. So here's the broadcast event, and we can see it is pretty heavy. Yes, pretty heavy, I must say so. We can see it is running at almost 20. That right there is just about a game killer right there. 20 is, oof, that's rough. So let's do an alternate version of that. So instead of the broadcast all, we're going to come down to this guy, and as we create all these objects and we have our count, I'm also adding them into an array. So we're going to add them all into an array, and then after we've created them all, we're going to loop through the entire array of all these objects, and we're going to send that event, well, not every frame, to that object, and then we're going to come back, and it's just going to go through. So that's one frame. In one frame, it's going to send 5,000 events. Comes over here, does the next frame, goes right back in, does 5,000 events again. So every frame's 5,000 events. Let's see how that pans out. Okay, so now we have frame rate is so low, it's not even doing anything. Oh, it's trying to do something. So this is us iterating through 5,000 objects in an array and sending an event 5,000 times every frame. And it is a monstrosity. Look at that. 1,730.
No. It's not true. That's impossible.
Dear freaking Lord. I could have went to the store and back. So I'm going to move this over to the do nothing. And in this guy, let's now turn on Raycast. Let's see how raycasting works. Are you curious to see the performance cost of 5,000 raycasts every frame? So there is 5,000 raycasts. It's not as bad as you thought, I bet. Raycasts can be heavy, no doubt, and they are, but in comparison to some of those other things we've seen, they're not that bad. Still, you know, 10, a little over 10, not that bad. Not that bad. Everyone has a big fear of raycasts because raycasts typically are known to be a heavy process, and that is true. But as you see, running 5,000 of them wasn't the end of the world, and you sure the hell don't need 5,000 raycasts. So let's do find object cat. Now the thing is about this action is it doesn't happen every frame, so I need to do a slight modification so that it happens every frame. There we go. So now we're going to find the object cat every frame. Let's see how that one pans out. Okay, so here is finding game object. 5,000 find game objects every frame. And, you know, it's pretty heavy. 23, like I said, that's pretty much in that game killer territory. But it is one of those actions that will scale with the number of objects, just like the broadcast. The more objects there is, the harder it is. Now, we already seen that if you need to send an event to a lot of objects, broadcast is far better than the send event. But if you're only going to send event to, you know, 10, 15 things, you're a lot better with send event than you are broadcast. So there is one more thing I wanted to show you. Two more things. Right, so that's finding game object. Let's do set velocity. Now, set velocity is a physics-based thing, so it happens in the update, or in the fixed update. So we need a rigid body. So right there, I'm assuming we should have higher performance costs. Okay, so here we are with physics now doing a set velocity, and as you can see, our bar is now gone stupid. We got multicolors, it's painting the whole thing. What the hell? Right? We now have a fixed update behavior of 112, and then 27 on top of that, and then we also have the actual behavior of 3, which is actually probably pretty close to the same thing as if you had none in reality, just for having the FSM. But I mean, that combined, that is game killer. That is your game ain't running. Setting velocity on 5,000 things. Now, you'd think we'd be done, but we're not. I want to show you one more little thing, and this is a sneaky little thing. Oh man, is it sneaky. And it caught me off guard. So let's just recap on this real quick. So if we do an int add, let's bring that up in our window. Okay, so here we have just the simple int add, right? And I just wanted to show you roughly, okay, it's there, right? We're building a graph with int add. I'm going to do one tiny change that should not affect it, but it's going to affect it, and you're just going to blow your mind. And that is, looking at this graph, we see int add. We see the performance cost. Now, if I add a state over here, I'm not even going to connect it to anything. There's no events to it. There's nothing's going to happen. And we're going to set velocity. Or you can add force, doesn't matter. And then I'm going to deactivate this action. It's just sitting over there. We're not going to use it. We're not touching it. We're not in that state. We're over here doing int add. And the fact that we have a physics-based action inside our FSM registers our FSM with the fixed update. Okay, so here we are now with the profiler, and we have int add. So we're still doing int add. We haven't changed anything else, but we have the one deactivated set velocity in a separate state on its own. We're not linked. Look at the difference here to here. This is int add, this is int add. The difference though is this one, there's a physics-based action inside the FSM somewhere compared to this. So we're calling 23 milliseconds on the physics update. We're not even using physics. We're not even using the set velocity. It's deactivated in a different state, and it's causing, because we have to register in with the fixed update loop. It's causing us a crap ton of performance for no reason. Where in reality, we're at 5. That's where we should be, and we're getting an extra 23 just because we have that action in there. So if you're building actions or you're building your FSMs, be aware about that physics. Don't just throw physics in all your FSMs and call it good, right? So we've learned a few things. Don't send 5,000 events all at once. That's bad. That's very bad. Physics actions anywhere inside your FSM is going to increase the performance cost of everything in your FSM just because. Finding game objects is also very hard. So there you have 3 things that could be killing you performance wise.